We are in homework 5, problem 1. In this problem, it gives us two random variables x and y, which are independent with each other. And the density function of x is equals to the step function of x minus 1 minus the step function of x minus 2. That's the density function of x. And also the density function of y equals to this, the step function of y minus the step function of y minus 1. Okay, so now we have the third random variable, which is related to x and y. Z equals to x and x plus 1. So now in this problem, we need to find the density function of z, and it let us use two methods. The first one, in the first method, we need to use convolution. So for the convolution, we have the density function of z equals to the density function of x, convoluting with y, and this is the formula. So this is the formula. So we put the equation of density function into this formula, and we got this. And so just do a calculation for this equation. We got this. So and then we need to divide the different cases. So for these cases, we just put this into this, and we got because the scale is from 1 to z. Z is a number we don't know, so the interval is from 1 to z, and we got this. So for this, it's 2 to z, and we got this and this and this, so in different cases. So finally, we just do different integral transmission calculation, and we got this, and we got this. So this equation is the density function of z in the step function form, and we have the picture. That's the picture of the density function of z. So that's the first method. And in the second method, we need to use geometric method. So we need to combine. So we need to use the geometric way. And for the density function of x, the picture is something like this, and this is the interval from 1 to 2, and also for y is from 0 to 1. That's the scale of that's the interval of y. So because z equals to x plus y, so z should be no less than 1 and no more than 3, x plus y. For z equals to x plus y, so we have this picture. Actually, for in x and y axis, y is equal to x, y equals to negative x plus z. So it should be like this. The intersect point should be z, and we got this. So for this in this point, so we have two different cases. When this line is in the left, when this equation is in the left of this line, that means z should be no less than 1 and no more than 2. So in this interval, we got the distribution function of z, and it should be the area of this line and with this square. So the distribution function of z should be like this. And just to the differential transmission, we got the density function of z is equal to z minus 1. So this is the result that z is in 1 to 2. So for different case, in the other case, z is no less than 2 but less than 3. So actually it should be like this. The line should be like this, and we need to get the area of this picture. So it's very easy. We just use the same way, and we got the distribution function of z equals to 1. 1 is the area of this square, and 1 minus this triangle, the area of this triangle, and we got this. So so this is the result of the distribution function of z in this interval, and also we got the density function of z equals to negative z plus 3. So all in all, the result of the distribution, the density function of z should be like this, and we can get the picture of this distribution the density function of z is like this. So the result is the same as the first method. So that's the whole things of the problem